Hello, good morning everyone. Today we will start class 10 chemistry. Chapter name is periodic classification of elements. Till now we have studied that at present around 119 elements are known to us. 119 elements are known to us. In these 119 elements, 94 of them are natural elements. Around 25 of them are artificial elements. So 94 has been made by nature, God, and 25 of them has been made by our scientists. They have made it artificially. And out of these 119 elements, around 88 of them are metals. Around 17 of them are non-metals. 8 of them are metalloids. And 6 of them are noble gases. This all we had seen in chapter number metals and non-metals. Here in this periodic classification of elements, what we are going to see that so many elements were known. It was difficult for our scientists also to remember their properties. So they tried to find out a way, a method, so that they could group the elements in a particular way, in a proper way, that would make it easier for them also to remember their properties, their characteristics, and about them. So this was started by Dobanian. What he did, around 9 elements, he arranged them in a proper order. That means he arranged them in a group of 3, and we call that one as the Dobanian's triad. So this work was done by John Dobanian in 1829. In 1829, John Dobanian, he came forward and he told us that I will give an idea how to remember the properties by grouping them in a proper way. So he grouped the elements in a group of 3, and we call them as Dobanian's triads. What did he do? He arranged the element in increasing order of their atomic masses in such a way that the atomic mass of the middle element was the mean of the atomic masses of the extreme elements. That means if we take his first group, as he had arranged lithium, sodium and potassium, he had arranged in this way in a vertical column. Then what he told, that if we take the atomic mass of lithium, atomic mass of sodium, potassium, and we add both and divide by 2, then we will get the atomic mass of the sodium. So lithium atomic mass 7, atomic mass of this potassium 39, and when we add both of these, 39 plus 7, 46, and when we divide it by 2, how much we will get? 23 we will get. So the atomic mass of sodium is 23. So this idea was given to us by Dobanian. Then he called this one as the alkaline metals. Why he called these metals as the alkaline metals? Because these metals, they dissolve in water and they form alkalis. We have studied in chapter number 2, acid, bases and salt, water, alkalis. All those bases that are soluble in water, we call them as alkalis. So these metals, when they dissolve in water, they form bases. and therefore these elements are also known as alkaline metals. Next, he had taken another group. What he had taken? Another group he had taken was calcium, strontium, and barium. Calcium, strontium, and barium. He had taken in this vertical column this way, and he told that the atomic mass of calcium is 40, atomic mass of barium is 137, and now when we add these two and we divide it by 2, we will get how much? So we will get 88.5, but the atomic mass of strontium is 88. So it is very close to 88.5. So what he did, he arranged again these three elements, calcium, strontium, and barium, in increasing order of the atomic masses, and he told that the atomic mass of strontium will be average of the atomic masses of calcium and barium. And these elements, he called them as alkaline earth metal. Why did he call them as alkaline earth metal? Because these elements are found in the earth crust in their oxide form, and these elements oxide, when they dissolve in water, then they form alkalis or soluble bases, water soluble bases. So these elements, he called them as alkaline earth metal. Alkaline, why? You understood, because they form bases when they dissolve in water, and earth because the oxide of these metals are found in the earth crust, and those oxides, when they are dissolved in water, then they form water soluble bases that we call them as alkalis. Next is the third group that he had taken, that was chlorine, bromine and iodine. Chlorine, bromine and iodine. He had taken this one. He had taken in increasing order of the atomic masses of chlorine, bromine and iodine, and the atomic mass of chlorine is 35.5, the atomic mass of chlorine is 127, this iodine is 127. Now when we add 127 and 35.5 and then we divide it by 2, so it is how much? Around 81.2. 127 plus 35. 7, 5, 12, 135, 16, 162. And when we divide it by 2, we get 81.2. But the atomic mass of barium is around 80. It is 80. Atomic mass of, sorry, not barium, bromine. Chlorine, bromine and iodine. So atomic mass of bromine is 80. So what we see here, what he had told, the way he had arranged in the increasing order of the atomic masses, that was very close to 81.2. He had told that when we add the atomic mass of these extreme elements and we divide it by 2, then the atomic mass of bromine we will get. So this way Bavarians continued for few years. We can say up to 1862, people, the scientists, the contemporary scientists, they accepted his idea, but when more and more elements were found, and the contemporary scientists questioned him that how would we arrange them in this group of tribes, he was unable to answer. He had no idea. He could not arrange them. So his this tribes theory was no more accepted. So we can say this one as one of the limitations of John Davenier's trad, that only 9 elements could be arranged in increasing order of the atomic masses, and when more new elements were discovered and they were being tried to be arranged, they couldn't be arranged in the way in which Davenier had told. So his classification was not successful for much time. Then we will see the next part. Next one will be our John Newland. This John Newland, he came forward in around 1862. Some books they write 64, somewhere you will find 64 also. So both of them are accepted. So around 1864 or 62 you could say, another scientist whose name was John Newland, he came forward and he gave us another idea. He told that we will arrange the elements in increasing order of their atomic masses, but not in a vertical way. We will arrange them in a horizontal way. We will arrange them in a group of 7 in such a way that the property of the every 8th element will be similar to the property of the first element. So how did he get this idea? From where did he get this idea? He got this idea. Why did he arrange in 7 only? Why not 8? Why not 6? Why not 9? So actually he had got this idea from the musical note, sa re ga ma pa di ni sa. So he had arranged this in such a way that the property of the every 8th element was similar to the first element. As we will see here, in this one, these elements, they have been given here the name hydrogen, lithium, barium. This is not as per the present periodic table. Earlier it was different. So fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium. In this way we will let me write this one also, cobalt and nickel one, and this way you will keep on. You can refer to your book also. Here I am not going to write all of them. So what we have, he had arranged around 35 of the elements in this way. What Davenier had done, he had arranged in vertical column. What John Newland did, he arranged in a horizontal way. And he arranged in such a way that the property of the 8th element, see here, first, second, third, fourth, fifth, sixth, seventh, 8th. So 8th one, that means these are similar in properties. Usually he says chemical properties. Now again we start counting from here. 1, 2, 3, 4, 5, 6, 7, 8. So these two will be similar in properties. Again we start counting from here. 1, 2, 3, 4, 5, 6, 7, 8. In this way, all we will see that the property of the every 8th element will be similar as it was told by John Newland. And then what he had done, in increasing order of the atomic masses. But two places he had put two elements in the same slot. See here, cobalt and nickel, here cesium and lanthanum. What he had done, he had put them in the same slot. We can say that this is one of the defects of his arrangement. What he had told, that we will keep the elements in increasing of the atomic masses, then in all other places he have placed only one element. Now how it is that in two places two elements are coming? So this is one of the defects or limitations we can say of the Newland's law octave. Law of octave, we will see now what is law of octave. According to John Newland, he had given the law of his table, of his arrangement of the elements. And what is that law? That law is that when elements are arranged in increasing of their atomic masses, then the chemical properties of every eighth element will be similar to the first element. And this periodicity will continue. And this law we call it as the Newland's law of octave. Octave means here 8, because he had told that the property of every eighth element will be similar. Next we have limitations. What were the limitations of Newland's law of octave? See, the limitation, one of the limitation we can say as that although at his time till 1864 56 elements were known, or we can say 56 elements had been discovered, but he was not able to arrange all of them in this table. In his arrangement of the elements, he was not able to place all of them. Around 35 of them only he could arrange. And that also what he had told, that the property of every eighth element will be similar, that was up to calcium only. After calcium, what he had done, that was just in increasing order of their atomic masses. The properties, the chemical properties were not similar. So we can say this as one of the limitations of Daubigny's triad, that he could not arrange all the elements known at that time. Second limitation we can say that he had put two places, two elements in the same slot. Third limitation we can say that he had told that we will arrange the element in increasing order of the atomic masses. Then why did he put cobalt earlier and nickel later on? Because what we will see in the atomic mass of cobalt and nickel, we will see that atomic mass of cobalt is around 58.7 and that of nickel it is 58. It is 9 and it is 7 in this one. So what he had done, that was a change. It could not follow what should be what he had told, that was not followed. He had told that we will arrange the element in increasing order of the atomic masses. Then this one cobalt, its atomic mass of cobalt is 58.9 and nickel it is 58.7. So according to his saying, according to his law, this nickel should come first and cobalt should come later. But he had put cobalt first and nickel later, so that was against his own theory. So this one we can consider as one of the defects or as one of the limitations of Newland's law of octaves. Another thing that we will see here that I have not written, let me write here in S1 here, iron. This iron, cobalt and nickel, they are very similar to one another in their chemical properties. So this iron, cobalt and nickel, they should be placed in the same slot, in the same, at least not same slot, but at least in the same vertical group. And here cobalt, nickel, they are much different in the properties with this hydrogen, fluorine and chlorine. Then this should not be placed here. But what he had done, he had placed iron so far away from cobalt and nickel, and cobalt and nickel were not in the same group in which iron should be there. So this is also one of the defects of Newland's law of octaves. Next part we will see next. So when 1864 or 62, whatever we see, different authors they write different way. So this Newland had come, he was unable to arrange all of them, all of the elements known at that time. Then after few years in 1869, Mendelif, although it is written Mendelif, but we study Mendelif. Dmitri Mendelif, he came forward with his idea almost 7 years we can say, if we count from 1862, and if we count from 1864, then it will be around 5 years. So till 5 years the scientists and the people accepted Newland's law of octaves. And after that, in 1869, this Dmitri Mendelif, when he came forward with his new idea, actually it was similar to what they had told the earlier two scientists, Daubigny and Newland had told, but he was successful in arranging the newly discovered elements. He was able to put all of them in the new arrangement, and he was wise enough to leave spaces for the undiscovered elements. What Newland had told, he had told that only 56 elements will exist in nature. No more elements will be found more. But after a few years only, more and more elements were found. So by his time, around 63 elements were known. And this genius fellow, he was able to arrange all of them in his periodic table. And not only that, he told that I am leaving some spaces empty for the elements that will be discovered in future. And also he had predicted properties of few elements like Eka silicon, Eka boron and Eka germanium. And when these elements were discovered later on, and what the property this Mendelif had told, and when it was discovered what properties was found of them, it was almost similar. So what had happened? He was more widely accepted by the scientists because what he had told was coming out to be true. And also he had told that when the elements will form oxides or when they will form hydrides, then their oxides and hydrides will have similar formula of all those that lie in the same group. Mendelif had arranged the elements in the way John Newland had arranged, that means in the way of horizontal way we can say. In this way he had arranged, but he had taken, this Mendelif had taken 8 groups and 7 periods, and around 63 elements he was able to arrange. So with what idea he came forward? What was his law? Mendelif told that the properties of the elements are the periodic functions of their atomic masses, and he had arranged the elements in such a way that the properties of the elements were periodic. That means it was repeating again and again, similar properties were coming. Now we will see his arrangement. So what he had done, he had placed in the first period hydrogen, then lithium, beryllium, carbon, nitrogen, oxygen, fluorine, and so on. I am not going to write again all of them. You can refer to your book. And then what he had done, in this way he had arranged periods. This was called periods, and the vertical ones were known as groups. More or less he had taken 63 elements, what was known at that time. He had arranged all of them. So what was his factor? 2 factors he had taken. That the properties of the elements will be repeating, and second thing was that he had arranged them in increasing order of their atomic masses. Next we come to merits of Mendelif's classification of elements. So I hope you all have understood how it is, as we have seen earlier, in the same way that the element that will lie in this first group, they will be similar in properties. Similarly, the second one, those elements that will lie in this way, they will be similar in properties, chemical properties mainly we say, and those that will lie in this way. So he had told in this way the elements will be similar in their properties. Now we will see the merits of Mendelif's classification of elements. Almost we can say 3 merits were there. One of the best merit we can say was that he was genius enough to leave spaces for the undiscovered elements. He had told that John Newland, what he had told? He had told that only 56 elements will exist in nature. No more elements will be found more. But he did not say such thing. He told that yes, 63 elements I am arranging them, but more elements will be discovered, and for them I am leaving some spaces, empty spaces. Second merit was that he had predicted the properties of few of the undiscovered elements, and when it was discovered later on, the properties was found to be much more similar to what he had told. And then third merit was that he had made the arrangement in such a beautiful way, in such a proper way, that when noble gases were found later on, they could be placed in the periodic table without any disturbance to the existing table. So we have taken much time, around it is half an hour. Now we will continue the next part another day.